So we have the subjects and the lecturer, right? So there is a relationship between the subject and the lecturer. So what is the relationship? It's convened by relation. So subjects are convened by the lecturers, right? So we establish a relationship, and then the first step is we need to then now establish cardinality of the relationship, right? Now, how to establish the cardinality of the relationship? So we need to travel from left to right and right to left. So if I travel from left to right, one subject convened by one lecturer. So the cardinality of relationship 1 comes here. If I go from left to right, okay. So the right to left, one lecturer can convene many subjects, isn't it? So the cardinality many symbol comes here, right? Opposite direction. Okay. So always we establish the cardinalities and cardinality constraints and the cardinality relationship by reading the opposite direction. Okay. One subject convene one lecturer can convene many subjects. Okay. Right. So this is entity instances. I think you know already. Entity instances means instances means the records, number of records here, right? So in this case, I have two instances. So each instance represent the values of these attributes, right? So there are set of values for each instance. Okay. And then here is the identifier. So you know what we mean by the identifier. So always we need to underline the identifier in our model, right? In our model. So here subject code underline, here lecture ID underline. So now remember these characteristics, right? So if you want to choose a particular column as an identifier, so these are the conditions that we must satisfy, right? So identifier might need to be unique, right? There is no duplicate values associated in that particular column, okay? And you can't have any null values. Now remember what do you mean by the null value? Null means not zero. Null means we don't know the value of that particular cell. That is what we mean by the null, okay? So that does not mean it's empty, okay? Right, so then what we need to do is once we establish the cardinalities or when we establish this model, we need to translate the model into the relational schema. So that means we describe this model or the picture, I would say, translate or transform into kind of English form so we can understand, right? So here the object lecturer become lecturer here, right? So capital letters, and then I'll open the brackets. Inside the bracket, I will list all the column values or the attribute values. And then I identify what is my primary key or the identifier by underlining the primary key. Okay, so sometimes we can write identifier name the line below. That is actually what I used to do, but sometimes you can underline as well. That's also okay. Right, so I'll skip this one. So this is how it looks like when you build your table in your database. So it's become a two-dimensional table. Yep. So we have columns for the attributes, rows represent the instances, right? Now remember the rows. We don't need to organize the rows, right? It is irrelevant for the organization of the rows, because as long as we have this primary key or the identifier, we can quickly pick the unique value without wasting time. So we don't need to sort these columns, right? As long as we have this primary key value. right? So these are the some kind of standards we need to use when you convert into the relational schema. Usually, as I mentioned before, the name of the table we need to write in the uppercase, right? And the attribute values, usually we write it in a kind of a capitalized lowercase, right? You can see the capitalized, the first letter capital, and then the second word also capital I capital. Okay, so here also L capital, N capital. So that these are the standards usually we use in the industry. Okay, so if you can stick with these standards, that will be great. Okay, so this is what we mean by the nulls. As I mentioned before, the nulls means we don't know the value, so we can keep a kind of a particular cell vacant. It does not mean the zero because we don't know the value. So we can't actually run any queries which we have nulls. So nulls actually gives lots of problems in the databases. If you have lots of null values in some particular columns, so that rings the alarm bells. Okay, so make sure you need to avoid null values. Some instances you can't avoid null values, but you need to think some other strategies how to avoid null values. Okay, so there are certain strategies we can implement in databases to avoid nulls. So we will learn that how to do that. Okay, so in this example, if I record all the lecture IDs, names, and ages in this table, so if I run a query to ask, okay, is Karen is younger than the John, we can't produce any result because we don't know the value of age of the Karen, okay, because it's not. It does not mean zero. It does not mean this Karen is younger than the John, or it does not mean the Karen is older than the age, older than the John, okay. Right, so we'll have some kind of discussions later on about the now, okay. Right, so usually for the identifiers, we give a kind of a special name primary key, right? So again, here I have described the same thing. These are the conditions that we need to satisfy for the primary key column or columns. It has to be unique. You can't have null values in the primary keys, etc., etc. And then make sure you underline the primary key name in your model, so others know exactly this is the primary key of your model. Right, so here now we have two entities. Now we're going to convert these two entities into the relational models. So we have the subjects and the lecturers. We identify the attributes, right? And then we identify what are the primary keys, okay? So this is how it looks like in the tabular form, right? So we have three lecturers or three instances to represent this object, and four instances to represent this object, right? So three columns, four instances. So when we convert into the relational schema, it looks like this. So lecturer become lecturer relation, subject becomes a subject relation, and then we underline the primary keys, okay? And then now we need to find out the relationships, right? So the relationship in this case is one-to-many type of relationship, because one lecturer can convene many subjects. So we establish that relationship here, okay? Convene relationship. And then we put the cardinality relationships. So one lecturer convene many subjects, one subject can be must come. So one subject convened by one lecturer. So one to many, okay? Now, one important thing that you need to understand here is what do you mean by this relationship? So how do we know the particular lecturer is going to teach a particular subject in the subject entity? How do we know that, right? Because we know that diagrammatically we establish that, but how do we really know which lecturer is teaching which subject or convening which subject, right? So for that reason, what we need to do is to establish this relationship in our database. What we need to do is we need to actually take this primary key and duplicate it in the subject column or subject database or subject entity, right? So that means we need to have another additional column here, which represent the primary key column in my lecturer table. Because if you establish that, then you exactly know which subject is taught by which lecturer or which subject is convened by which lecturer. So therefore, we need to duplicate this column here, right? So we are giving a name. Once to take this column here, the primary key column to other object, we give a special name. That special name is called the foreign key. So primary key now becomes the foreign key in the other related table, right? So we have primary keys and we have now foreign keys, okay? Now one rule is, always foreign keys goes to the many end, right? Always, if you see in a model, there is a many end attached to a particular object or particular entity. That object actually has the primary key as a foreign key in that particular entity. Okay, so in this case, many end has the foreign key. So that means when you extracted or transform this object into our relational schema, now our relational schema has an extra column called lecturer ID. So that is the primary key column comes there. Okay. So I have 3 columns plus 1 additional column, foreign key column. So 1, 2, 3, 4. So now I have 4 columns in this my subject column, subject table or subject entity, right? So when you implement that in a database, so yeah, our database, it looks like this. So when you create our table, it now looks like this. So we have an additional column. So actually, what do you mean by this additional foreign key column means? Now, if you go through each instance, you can see INF10005 Introduction to Web is stored by lecture ID 207. So lecture ID 207 means we can jump to the lecturer table now and then go through the instances and see who is this 207 means, who is the lecturer, what is his name, what is his age, what is his address, etc., etc. So everything can be grabbed once you know this foreign key. So that means once you establish this foreign key, we can actually properly establish this link between these two entities. Okay. But one important thing that you need to know, I'll come to that a little bit later on. Now, this example actually exactly explains what I explained earlier. Once you establish the link, you can navigate it through and see the other information related to the lecture. Okay. So foreign key now acting as a lookup search key for the primary key value in the related table, right? So, for example, if somebody asks, "Oh, what is the age of the person who convening HPA 30088 subject?" Okay. So then I can actually find that answer for that query, right? So HPA 30088 convened by the lecturer number 207, and that person's age is 37. So likewise, I can actually navigate and find out the answers to any query once you establish this relationship between the objects by using the foreign key primary key relationship. And the other important thing about why we establish these foreign keys in the related table is now foreign key can be act as a constraint. What do you mean by that? We usually call the foreign key as a constraint or foreign key constraint. The reason is that, right, say for example, when a person try to enter some data into the subject table, if he put kind of lecture ID, say in this case 444, type 444 and press enter, it will give you an error message. Why? We don't have any matching value representing this 444 in my other table, right? So that is another advantage of having the foreign keys, because now we can validate any values that the users are entering into the foreign key field with its related primary key field of this other entity. So we can easily validate, isn't it? Right? So if I put 444, I will get an error message because there is no 444. If I put 119, it will say, yes, I got it because the 119 is there already, right? So that is another advantage. So usually the foreign keys, we call it as foreign key constraint because of that reason, because it validates the related primary key values in the other related table, right? The other important thing that you need to know is, unlike in primary keys, you can have null values in my foreign key column. For example, now think about an example here. I am going to introduce a new subject in next semester called COBOL or more COBOL. So the subject code is INF100, right? But I haven't decided any lecturer who is going to teach that subject. I don't have any idea at the moment who is going to teach it, right? So that means I can put a null value here. By the way, this is how we record the null, right? We don't put 0, we just write NULL, right? So that is perfectly okay. Okay, null values are perfectly okay for the foreign key columns. So nulls are allowed in the foreign key columns. Okay, so that is something that you need to keep remember. For the primary keys, nulls are not allowed, but for the foreign keys, nulls are allowed. Okay, so something that you need to keep remember. Right, now we can actually complete our relational schema. So we have now the lecturer relation, subject relation, and now you exactly know, right? There is another column comes to the subject relation, that is my foreign key, lecture ID. Then I need to tell this line. Then I need to write this line. I need to write foreign key, lecture ID, references the lecturer, right? So when you write this, we should know that, okay, what do you mean by this line is this foreign key value, like ID value which reside in this column is need to match with the primary key value of the lecturer table. That is what we mean by this line. Okay. So always remember, when you convert the model into the relational schema, you must specify this sentence with respect which table it belongs to. Okay, so here foreign key belongs to the subject table, therefore I need to write this sentence. Okay, so always remember foreign key goes to which end? Foreign key always goes to many end. Okay, so subject is the many end, has the many end. Okay, this is something you need to remember. Right now, I will ask a question from you guys. I want your answers, all right? So you can type your answers. Now think about this small model. So what is this small model? Now let's go through this small model. So we have departments, we have workers, right? So it looks like workers are working in the department. So departments are employing workers, right? So let's go through this cardinality relationship in this case. One department employs many workers. One worker works at one department, isn't it? So one worker works at one department. Right, so that is the relationship or cardinality relationship. Now I am asking this question. When you convert this model into the relational schema, question number one, how many columns will be exist in the table worker? Second question, how many columns will be exist in the table department? Right? So this is one-to-many, yes. Cruz, yes, it's one-to-many type of relationship. Yes, one department employs many workers. When you actually express the relationship, this is one to many, but you express in the other way as well, many to one, right? One worker must one worker employed by one department. Yeah, right. For the first question, how many columns? Worker 4. So most of you have saying it's 4, right? Shenal says 5. Shenal, you are correct. It's 5. Why it is 5? Now remember, if you have this many end, what do you mean by this many end? What do you mean by this many end? Many end means my primary key in the other end comes there as a foreign key, isn't it? Yes. So that means there is an additional column there, but we are not actually going to show that in our model, but it implies from this notation here. It implies that there is an additional column is there. That is my primary key column of the other end. Okay. So we have how many columns there? 1, 2, 3, 4 plus department ID comes there 5. So the answer for the first question is 5. Am I right? Yes. How about the answer of the second question? How many columns will be exist in the department? How many columns exist in the department? 4? 3. Not 4, right? Because we have 3 here. There is no foreign key, right? There is no many end attached to here. Okay. Many end is here, not there. So we have 3 columns, right? So department ID, department name, address. Right. So don't worry, we'll do plenty of questions next week. Okay. So I just wanted to show how it works. Right. So that is about the relational schema. Right. So I think what is this? Yes. So it's confusing part of the terminology because of the terms, right? Sometimes the cardinality relationship, cardinality constraints can be a bit confusing. But once you clarify it, it's very piece of cake actually. It's really easy. It's very fun to model the databases. So I'll make it very fun. Okay, so don't worry. At the end of this semester, you will say, okay, you will tell me, oh, database is my favorite subject. That is what I wanted to. Everyone wanted to say that, right? End of the semester. So I'll make it happen. So don't worry. I will guide you for that. Okay. Right, so right, let's skip this one. I think I have already done that. Right, so the other important thing is right now we have imagined that we have now converted our model to this relational schema, right? Now before we convert this relational schema into our database model, or we write kind of codes to the database who can understand this model. we need to actually know what kind of data we going to record in each of these columns, right? So we have columns here, can you see? So how many columns we have? Lecturer 3 columns, in the subject we have 4 columns, right? So we need to know what are the data, what type of data we going to record here, right? So so each column actually become, or each attribute becomes a column in the database, right? So we need to now specify what kind of data we can record. And also we need to specify the length of the data, right? For example, if I trying to record a name for in this particular column, lecturer's name, how many values? So how many, what is the space? So can I put 10 characters or 20 characters or 30 characters, right? I need to specify the maximum length or character length for the lecturer's name. So similarly, if you record some numerical value, I need to tell the database management system how many digits I want in that particular column, right? So the maximum length can be specified, okay? Right, so Casey, you have a question. Will all many to one have a foreign key? Yes, Casey, yes. So many, always if there is a many, that means there is a foreign key, right? Except one to one, okay? But one to one also we need to have, one to one need to be deal with some other means. So we'll come to that later on. But always think about many end attract the foreign key, right? If there's a many end, always there's a foreign key, okay? Right, so the data, Casey, did I solve your query? Yes, so yeah, okay. Right, so we need to tell the database management system what kind of data we are going to record in each column. Now, in Oracle or in database management system, basically, if you record the character type or text type of data, we actually refer to it as vacha, right? Vacha stands for variable characters, right? So here this example says vacha 30 in the brackets, right? So what they mean by vacha 30 is, in a particular column, my number of characters I can record up to maximum 30, right? For example, if it is a lecturer's name column, I can say that to the Oracle database management system, okay, Oracle, this particular column can have only maximum 30 characters, right? This is how we specify, this is how we tell the Oracle, okay? Right, now we are coming to SQL language, right? Now we know how to construct the model, how to establish the relationship, and how to establish cardinalities, and then the cardinality constraints. And then we converted the model into the relational schema. And now it's time to convert the relational schema to machine readable form. So that is why we need the so-called structured query language, SQL. Okay. So that is the language, that is a standard language that relational database management system can understand. Okay. Right. The first thing first. First thing what we need to do now, when it comes to structured query language, we can actually divide this language into two parts: data definition language and data manipulation language, right? So when you create the tables, when you create the objects, right, this comes under data definition language. When you do any manipulations to that particular table, it comes under data manipulation language, right? So if you want to, for example, creating a table, if you want to altering a table, if you want to delete a table, everything comes under data definition language. Okay, so if you want to update something or delete data, or you want to insert data into a particular table, or querying something from the table, it comes under data manipulation language. Okay, and then there is another part is called the data control language. So this is actually exclusively used by administrators who can specify the access rights for the data. Okay, so we are not going to touch that one. Okay, data control language part, but we touching these two, DDL and DML. Right. So the first thing is, now we know exactly our relational schema. Now how we are going to create a table in the database management system. So this is the syntax that we are going to use to create a table, right? So we write these statements. So create table. So this is a keyword, right? And then we give a name of the table, okay? And then we open a brackets. Inside the bracket, we specify all the columns, right? And the data types, okay? And also if you want to record the maximum length, we can put the maximum length. Actually, maximum length is optional, right? So you can see this brackets, it says the optional, okay? And then I need to specify what is the primary key of that particular table. So I write the keyword primary key, and then inside the brackets I write what the column name of the primary key. And then I write, if you have any foreign keys in that particular table, I can write foreign key, a keyword again, name of the column, references, the other table name. Okay. Now, when you write these SQL, these are called SQL statements. So when you write this SQL statement, keywords are not case sensitive. Okay, in Oracle, it's not case sensitive, right? You can write in upper cases if you want, but it's not compulsory. It's not case sensitive. Okay. All right. Now let's come to this example. Our example. So remember, we have two objects, so two entities, lecturer and the subject. So this is how we create the table for these two, right? Now remember one important thing, right? One important thing, this is what I want to actually keep remembering you. So when I go back to my model, this model, so imagine we have these two, right? So if I want to create the tables in my database, which table I need to create first? Can I create subject table first, or can I create the lecturer table first? What do you think? Lecturer first. Vanessa says lecturers. Is it lecturer or the subject? Vanessa, why it is? Chanel says yes, lecturer. Kunjal says the subject. Why? Now the answer lecturer is correct. The answer lecturer is correct. The reason is we can't create the subject first. Why? What is the reason? Why we create the lecturer first? Yes, Liam says. Liam, you are correct, because the foreign key, right? We first need to create the main table first before we create our secondary table, because this is secondary table because foreign key goes there. If I try to create this with the foreign key, what will happen? Oracle will confuse. Database management will confuse because there is a foreign key which is actually don't have any relationship, because we haven't established this yet, isn't it? It will confuse. So we need to first create the main table, and then we'll create the secondary table or the foreign key table, right? So that is why here in this case, I first create the lecturer table, and then I create the subject table. So in the lecturer table, I can write the create table statement. I write the create table, lecturer, the name of the entity, open the brackets. Now, one important thing, guys, these small bits and pieces. Now, each time when they're, now can you see these commas? So each time once you finish a column, you need to put a comma, right? So that is, and then there is a semicolon at the end. Semicolon is a statement separator. Okay, statement. So this is a one statement. Okay, and this is a second statement. So each time make sure that you put the statement separate. Okay. So in this case, right. So when create table lecturer, we write the lecturer column names. So once you put the column name, and then you need to specify what kind of data it goes to that particular column. So in this case, lecture ID is a numeric. So in database management systems, numeric we call it as number. Okay, so number in this case I don't specify the number of digits. I just put number. Okay, the comma. So I just put the comma here rather than putting here. You can put it there actually. And then the second column name. So second column name is the lecturer's name or name. It's characters, right? It's not numbers. So vacha. So I specify maximum characters, 50 characters. And then again the comma, right? Comma goes there. And then this third column age here I specify as a number as well. So there is another data type called date data type. You can use the date data type if you record like birth date or whatever the dates you want. But mostly I don't use it because it sometimes date types are very confusing sometimes. But for the learning purpose, let's focus on numbers and vachas in this semester. Okay, because data type is a bit complicated. We'll come to that later on. Okay, right. So the age in this case I specify as a number. And then once specify all the column names, I need to tell the Oracle or the database management system what is the primary key of this particular table. So I just write primary key. Now this is a keyword. And then open brackets. I need to specify what is the primary key column in this particular table. So in this case, like ID. Okay. And then close the bracket. So this is the open bracket. This is the closed brackets. And end of the statement. So likewise, I can do the same here. Okay. But in this case, once I specify the columns, I need to make sure I specify one extra column like ID, right? That is my foreign key, right? This primary key becomes a foreign key, right? Now, the column names, right? Column names, you can have any column name. It need not to be identical name of the primary key column. But the data type must equal to the data type of the primary key. That is very important. Okay. So the column names need not to be equal, but the data type need to be equal. Okay, that is the condition. Okay. And like earlier, then I can specify what is the primary key of this subject table, subject code. And then I have another extra sentence, right? So I need to now tell the Oracle what is the foreign key of this particular table. So foreign key, lec ID, references, lecture. So this is a keyword. This is a keyword as well. Okay. Right. So once you specify this, what we can do is when you press enter, the Oracle or the database management system will create two tables in the database. Then what's next step? The next step is we need to insert records, right? So how to insert the records into these tables? So this is the syntax. So this is the statement we need to use. Insert into statements. Okay. Okay. So in this case, I am inserting some values to the lecturer table. Okay. So this is the syntax, insert into the table name, and then the open brackets. Inside the brackets, I need to specify column names followed by the commas, and then I tell the values. Values, again open the bracket, I tell which values are corresponding to each column. Okay, so this is an example. Here I am inserting one lecturer, so I specify all the column names. So there are 3 columns, like ID, lec name, and the age, and the values corresponding to these columns are 207, John Smith 37. And one important thing, again, you need to remember when you inserting the numerical values and character types values. So when you insert the character types values, remember it has to accompany with a single quotes, not the double quotes. Make sure if you put the double quotes, you will get an error message. Okay? Single quotes. If it's a numeric value, there is no quotes at all. We just type the numeric figure. Okay. And again, make sure you put the statement separate at the end, semicolon. Okay. Right. So now that is the one reason why I ask you to use the Notepad++. Don't use Microsoft Word or Word documents to type your codes, because what will happen is Word put some smart codes, right? They have smart code features, right? So can you see these codes, right? If I use a Notepad, a Word, the code symbol looks like this. But if I use the Notepad++, code symbol looks like this. These two symbols have different meanings. For the human eyes, it looks same, but for the machine eye, it's quite different, because machine can understand ASCII codes. So ASCII codes are different. Okay, so make sure don't use Microsoft Word, because they may have a hidden characters like this, which we can't see as a humans, but machine can understand. So you'll get an error message. Okay, invalid character error message. So that is the one reason why I ask you to use Notepad++ or any other text editor rather than using Microsoft Word. Okay. Right. So there are a bunch of insert statement here. Now here I am inserting 2 records to the lecturer table, right? Lecturer number 207, John Smith, and lecturer number 3034, Carol Kent. Okay. And then I'm inserting 2 subjects into the subject table, HIT1405, Introduction to Web, and HIT1407, EBIS, right? Introduction to Business Information System, or sorry, Electronic Business Information Systems. Right, so now sometimes, as I mentioned before, I can put null values in my columns. For example, in this case, I am inserting a lecturer called Raj Vasa in my lecturer table, but he doesn't give any his age, so I just put null. Okay, so I just put NU double N null. All right. So Casey, you have a question. Do we use null so we can update it later? Yes, we can. Yeah, we can update it later. Yes. Yeah. So for example, if I insert lecture, he said, okay, I don't want to specify, but then later he will say, okay, I'll give my name, age. Then I can run an update statement to update this specific value. Okay. Yeah, you can do that. You can do that. We'll come to that update statement later on. Okay. So at this moment, we just know how to construct a table and how to insert values to the table. Okay, or rows to the table. Right. So once you put in values or the rows or instances into the table, now how are we going to produce some reports? How are we going to extract information from tables and produce some meaningful reports? So to do that, we need to have another syntax or other statement called select statement, right? So when you use a select statement, I can extract some information from the table. So this is the syntax select. Then I specify the column names, which columns I am focusing on, and from. I need to specify which table these columns are coming from. So that is what we mean by from. Okay, table name. So this is an example. In this example, I am extracting lecture ID, lecturer name, and the age columns from the lecturer table. Now remember, when you specify the column names, make sure you separate it by column name separated by commas, okay? And then from lecturer, end of statement separate, okay? So what does it mean actually? What do you mean by this select statement? Extract whole columns, whole 3 columns from the lecturer table. So whatever the data I recorded in my table, doesn't matter how many rows I have in that table, it will bring the whole table back, because the lecturer table, I have 3 columns, right? Lecture ID, lecture name, and age. So I'll get the whole table back, something like this as an output. Okay. So the sequence of the column names in the select clause matches the sequence of the columns in the result set. Right. So you can see the first column is lecture ID. Here is lecture ID. Second one is lecturer name, age, and age. Okay. Semicolon at the age, no channel, because this is a one statement, right? Select from is a one statement. So this is where the statement ends. So don't put the end of separator here. You need to put separator here, okay? So select column names from lecture, okay? So don't put it here because this is a one single statement. Select from, okay? Make sense, Shana? Okay, all right. Right, now I have a bunch of other examples. Right, the second example here, now here in this case, I am selecting only 2 columns, right? So select lec ID, lec name from the lecture. So I'm getting only 2 columns, right? But for the whole table, yeah. In this case, I am getting, now here I have arranged in a different way. I want to get the age column first and the lecturer name column second, right? So I just write the statement, select age, comma, lec name from lecturer, semicolon, right? So this is my output looks like. And there's another shortcut method. If I want to get everything in the table, so whole table as is, I need to produce as a result. What I can do is I can use the asterisk symbol. Can you see the asterisk mark here? Star, right? I can use the star, right? So select star from lecturer means I'll get the whole table as is. So it arrange according to the columns I have specified. Okay. Can we write in the lowercase Kunjal? Yes, yes. I can write, you can write in, it's not case sensitive. Yes. Yeah. Column names, table names are not case sensitive in Oracle, but some other database systems, it's case sensitive, but in Oracle, it's not case sensitive. That is a good thing. Okay. Right. Okay. So, right. Now you can see this, the result set I'm getting back is organized in a kind of a different way. But if I want to organize in a some kind of meaningful way, like descending order or ascending order, I can do that, right? So there is a 2 powerful keywords one powerful keyword in Oracle database management system is called the order by clause, order by keyword. For example, in this case, say I wanted to get all the lecturer names and the age from the lecturer table, but I want to order it by according to lecturer name order. So what I can write is order by column name. So this is the column name I want to order it. Okay. So you can see here it ordered it according to the ascending order of the lecturer name. So C comes first, JA comes first, and JO comes next. Right? So in this second example, if I wanted to order it by lecturer name, but I wanted to order it by the other way around, descending order. So how can I do that? I just write a small keyword here, DESC, descending. That is what we mean by the descending. This is a keyword, okay? DESC. So select name age from lecturer, order by lecturer name, but I want descending order, DESC. Okay. Now, in normally the default order is ascending order or ASC. I can actually specify it if you want, right? So in this case, I'm order it by according to age, ascending order. But in default, if you ignore AAC, it actually order it according to the ascending order. Okay, it's the default one. But you can specify it if you want, right? So this is the order by clause. Okay, so order by clause is a very powerful clause. I can order it by any way I want. Okay. So Casey, we have a question. Is that why you said it doesn't matter what order we enter? Yes, that's right. Yeah, so it doesn't matter what order we enter the data, because when you extract the information, I can order it by any way, right? Because by using these clauses. Yeah, there's another reason. Yeah. The other reason is order is not important because we have the primary keys, isn't it? From the primary keys, we can jump to whatever the record I want, right? Rather than, sequentially read one by one, isn't it? So that is why order is not that important as well, because we have the primary key and also we have these order by clauses. We can order it in whatever we want our results. Okay. Right. Sometimes we can order it according to the column number. Right now, I actually don't like this method. But it's okay. But sometimes when you write the complex queries, we can do it like that. For example, in here, now let's go through an example. So here I am selecting 3 columns. So the first column is the first column. Second one is the second column. Third one is the third column, right? So column list, this is the list I specify in my select statement. So I can write order by according to 3. So 3 means Oracle knows 3 means third column in this select statement. Okay. Right. So the result set looks like this now. So order by 3, descending order. So age, the 3 means age. Okay. Why I am actually not good in this is why I am not asking you to do this unless you are writing a very complex query, because the reason is very next day if your boss comes and asks you, okay, Ravinder, can you put another column, right? In my report, if I put another column here, and then what will happen if I forgot to put this, adjust this 3 to 4? My output now looks different, isn't it? So you should be very careful when you put this order it by according to this numeric value, okay? Column number. So if you, unless you're writing a complex one, don't use the column number to order, okay? Results. All right. Say like now let's go through. So now here this example, we can order our result set according to multiple columns order as well. Now think about this table. Now this is my original table. You can see in my lecturer table 3 columns. This is how I originally record all the values. So if I wanted to run a query like this, so select lecturer name age from lecturer, okay, but I wanted to first order it by according to age order, and then I wanted to order it by according to the lecturer name order. What do you mean by that? So you know the age is a numeric value, right? So according to this query, it says first order it by age. So you can see it's ordered sequentially in a ordered by age range. So 21 comes first, 26, the bunch of 26s there. There are two 34s, so three 34s and one 37. Okay, and then the lecturer name mode. So what do you mean by that? After you arrange it like this, then arrange it according to the lecturer name mode. So you can see in 26s there are 3 lecturers. So these names are arranged according to name mode. So A comes first, JA comes next, JI comes after. Again 34, there are 3, B comes first, C comes next, S comes next. Right. Now you can see the order by clause is very powerful clause. So we can do whatever the order, right, by using different columns. Okay. Right. So what is this? Yeah. So these are the common errors you will get when you run SQL statement because of these reasons, right? Because sometimes you will forget to put the commas between the column names in the select statement, then you will get an error message, right? Or sometimes you will misspell something, right? Misspelling keywords. That is why we use, I ask you to use word Notepad++ because it will highlight the keywords. It's easy, right? So if you use something else, you will misspell the keyword, then it will generate an error message. So here, select is wrong, isn't it? And then here, from is wrong as well. Okay, keywords. So these are the keywords. And sometimes we will misspell the table names as well. So lecturer, not lecture. Okay, and sometimes we will misspell the column names. Right. So column names, table names, if you misspell, it will not going to catch by Notepad++. This is not syntax errors. So unfortunately, then if you get an error message, you need to actually go through and see whether it belongs to, it's a misspell of column name or misspell of your table name. Okay. Unfortunately, you need to do it by manually. But errors will not typically will cause if, as I mentioned before, if you write in the simple cases or if you put spaces, if you put multiple lines, it's okay. But even some, mostly if you ignore the semicolon, you will not get an error message. But this is a good programming habit, right? When you write the statement, always make sure you put the statement separator because it's a good programming habit. Now remember, as mentioned before, since we are starting from the scratch, from clean sheet of paper, always try to learn good programming habits. It's very easy, right? Once you, because the thing is this, sometimes you need to communicate these codes with other team members. So sometimes they may confuse if they run and if they get an error message. So always make sure you stick with the good programming habits, okay? So these cases, you will not get any error messages. So upper cases, lower cases in the column names or table names or spaces. If you break the code into multiple lines and if you forgot the semicolon, so it's okay. Okay. So usually this is actually way I usually write the codes. So when you write the big codes like or big statement like this, I just trying to I usually write it in the uppercase, the keywords, but it's not compulsory. Sometimes when you write lots of statements, you can't, just swap with, you can, you can't go with uppercase and lowercase. So, but it's a good programming practice, okay? Right. Now we are coming to another one, where clause. Right now, early example, you can see when you run the select statement, early examples in these cases. When you run the select statement, we are grabbing all the whole columns, right? The whole columns and the data values associated in all the columns. But what if I don't want some value? So if I want to get rid of some column or some rows, how can I do that? So I can do that by using where clause. That is, you restrict some of your records comes into your report. Restriction. This is where we put the restrictions. Okay. For example, now let's go through an example here. So usually this is how it flows. First, we need to write the select, then the from clause, and then the where clause. Okay, and then order by clause. Okay. Right. So in this case here, I am selecting star means everything. Select everything from my lecturer table, from lecturer. But I don't want the lecturers whose age is greater than 35. I want people less than 35 years of age. So I can restrict something using where clause. I can write where age less than 35. Okay. If this condition is true, then I will get the result set which matches this condition. Okay. This is how I put the restrictions. So there are a bunch of examples here. Right, now these are the operators I can use to restrict the data that I derive from the tables. Right, operators. Now these are the common operators. So equal sign. So if I want to match exact matches, right? If I want to match exactly with some value, I can use the equal sign. So this is not equal, right? So in the database management system, there are a couple of not equal signs. I can use this sign to greater than or greater than less than symbol. So I can use this exclamation mark followed by equal sign as well, right? But actually, I rarely use this symbol. I actually use this one, not equal. Okay, and this is the less than, right? This is another operator I can use. Or sometimes I need to use less than or equal, right? So less than and the equal sign. Or sometimes I need to use greater than or greater than or equal. Right? So these are the common operators I can use. So I have a bunch of examples here using these common operators using the same lecturer table. Right, so if I run this queries, now let's go very quickly. So what does it mean? Select everything. Star means everything. Select everything from my lecturer table. So that means select whole table. But I want the age is equal to 34. If this is my original table, how many rows I will get? What are the rows? What are the lecture IDs I will get? Age is equal to 34. So we can see there are two records which matches this condition, isn't it? So lecture ID 404 and 118, right? So I'll get the answer for that. Okay. So what do you mean? Now, what is the result looks like in this case? Select everything. So my result set now looks like. So my table looks like. So I'll get the whole table. I mean whole column. So how many columns I got here? 1, 2, 3. Lec ID, lec name, age, right? So lec ID, lec name, age. So this is lec ID. Sorry, I just put lec ID, lec ID. This is lec name. I'm using my mouse. Sorry, guys. Very difficult to write. Lec name and age. So I'll get the two values, right, for the first query. Sorry, two values. 404 and 118. So 404 and 118, and all the other values associated with this, right? So that is the result set generated by this square. So second one, age is less than 34. Age is less than 34 means everybody less than 34 except 34, okay? So 521, yes. 103, yes. 119, yes. Right? 231, yes. So 1, 2, 3, 4. So these 4 rows will come back as a result set. So where age is less than or greater than, what do you mean by this? This means not equal, yeah. So age is not equal to 21 means apart from 21, I'll get everything else. So 6 rows, right? So 1, 2, 3, 4, 5, 6. So likewise, you can actually play with this. So this is called greater than or equal to 34. So this is equal to 34, right? So then or equal to 34 means these two and 37. So 3 rows. So likewise, you can play with it. So this is a very powerful operators as well. You can manipulate the result set as I want by using these operators. Right. That is about the operators, and then you need to be very careful when you use the numerical values or numerical literals in my queries. Please don't use any quotes or any formatting symbols, right? Because it will generate error message. Like here, if I put a comma here to separate 50,000, 50, so it's wrong because Oracle can't understand this. And also don't put quotes because quotes means character type data, right? So if it is a name, don't put quotes, single quotes, okay? Decimals okay, and minuses are okay. Negative signs are also okay, right? So that is about the numeric values. But when it comes to string values or the character type, make sure you put the single quotes, right? So don't put the double quotes. If you put the double quotes, you will get an error message. Even if you ignore the quotes, you will get an error message. So make sure whenever you want to use characters or literals, character literals, make sure you use single quotes. Okay. Right. So right now, one important thing that I need to tell you again is case sensitivity of the data. Right now, Oracle is not case sensitive for column names and the table names and the keywords, but it is case sensitive when it comes to the data, right? Percentage sign, yes, percentage sign, Kunjal will come to that a little bit later on. Yes, so there is a one way we can use percentage, right? So I will let you know when to use percentage sign. Okay, right. So when it comes to the data, the Oracle is very case sensitive, right? For example, in this case, Jane Pitt. Now we have two Jane. Now in these queries, I have put two Jane. Now here uppercase version of Jane Pitt and the lowercase version of Jane Pitt. So these two are quite different when it comes to Oracle, right? So if I run a query like select blah 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 from lecturer table where lect name is equal to uppercase Jane Pitt, I'm not getting any results set back because uppercase, there is no uppercase Jane Pitt here. But if I run this one, first letter J is capital and P is capital only, I'll get one result set, right? Because this matches with the third row in my table. Okay. So make sure when you try to use data values in your where clause, make sure you use the exact match. So there's another way we can actually, there's a shortcut method. I'll let you know what to do in that case. Right, now this is a good coding standard, guys. When you write the codes, usually I don't write the code something like that. See this code, this select statement, it's very, actually Oracle can understand, but we can't understand, right? The human, it's a bit difficult. So always write a code something like this, right? So this is a very good style. So when you write the keywords, stack the keywords one after another, and then the column values and the data values in the right hand side. Okay, so select this. You can see this statement, right? So this is very human readable form rather than this one. So same code, but two different ways to write it. So I don't promote this one. So make sure you use this standard. Right, so you know how to use ISQL Junior. I think I told you last time. Now, so when you create your table, sometimes we need to find out what are the tables I have created in my database, right? So in order to do that, there is a way that we can grab tables. Now, how to do that? Now, remember that I told you when you create in the modern databases, the databases tend to maintain separately maintain data dictionary, right? Or what do you mean by data dictionaries? I think in the very first lecture I mentioned or metadata, in other words, metadata, right? So it keeps the data about data in a separate table, right? So in Oracle keep all your databases and all your data that you input into your databases or data files in a separate table, in a separate tables in metadata form, right? So I can actually access that table, but I can access Oracle data dictionary table and see what databases or what data files I have created, right? This is how I access that, okay? So if I wanted to access the name of a table, I need to use select table underscore name, right? From user table. So the database or Oracle keep a table called user underscore table to maintain or to keep the record of all the tables that we created in our database. So I am accessing the user table, right? And I am getting the column called the table name column to see the tables I have created, right? So sometimes I can use, rather than using user tables, I can use tabs. So that is an Oracle shortened form or shortcut version for the user tables. Okay. And then once I get all the table names, because sometimes we need to do that, because if you say, for example, in any database, we create 100 or 200 tables, we can't keep remembering all the names of the table. Yeah. So we need to access our data dictionary and see the list of tables we have created, right? And then once I get to know which table I wanted to analyze, what I can do is I can run another command called describe, right? Because when you run the describe the table name, right? This is the table name I wanted to see. I will get the specification of that table. So what kind of columns I have in that table, whether what type of data I'm going to input in each column, right? Whether the particular column is, you can put the null values or not. Now in this example, you can see a nullable column in the movie table. So movie table, I have n here, right? What do you mean by n in this case? Everything else is y, 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 y. Why it is n? Because movie number is probably my primary key, right? So primary keys cannot have any null values. So that is the reason I get n here. All right. Right. Okay. You don't need to actually worry too much about this because I'm not going to test it. This is for your own for your information. Okay, this one, this 73 slide. Right, so once I create tables, can I delete the tables? Yes, I can delete the tables. So how can I delete the tables? So this is the keyword, drop table, right? So drop table, then I need to specify the name of the table. So for example, drop table student, command, then it will drop the table. Now remember, it's very dangerous, okay? Very dangerous when you go to the industry. If you drop table student, then what will happen? Boom, gone. All the student data will go, right? There is no undo, okay? So you need to be very, very careful, because usually in the databases, database administrators will not allow normal users to execute drop table commands, okay? Right, so this is how you access the Oracle. As I mentioned before, Oracle database, we are using Oracle database, and there is a web interface, right? Web interface. So we are using the web browser to communicate with the Oracle database. So that web interface is called ISQL Junior. So this is the link. So I think I have given you last time, so you can use this link. I'm assuming that everybody has the connection now, right? So initially you need to use the date of birth, and then you need to set up your own account, and then it will guide you. And the database name is simple case DAD. DAD. This is the database we are going to use in this semester. DAD. So we create all our tables, your tables and my tables, in the database called DAD database. Okay. Right, so Oracle account, make sure you don't share it with anyone else, right? So it is restriction. So they have restrictions. So please make sure you don't share it with anyone else. Okay. So you can use this in web, because if it's a web interface, you can use it with your mobile phone or whatever. Even if you traveling somewhere, you can still use this if you have internet connection. Okay. That is actually very good thing. You can't even avoid deadlines, isn't it? Somebody can't say, okay, because my computer got problems or issues, because you can use your mobile phone to execute your Oracle, database. Right. Yeah, so make sure you put a semicolon when you write this is a good programming habit, as I mentioned before. So what we can do is, usually what I do, I write all these commands, not directly in the Junior, but what I do, I write all the commands and statements in Notepad++, and then I select all and paste it into ISQL Junior and click execute button. Then I'll get the result set, something like this. So result set will come immediately below that text box. Okay. So you will see immediately the result set. So if you get an error message, it will display here as well. Right. So in week 2 in lab, we'll do some typings, or we run some queries, we create tables. Okay. So make sure you have these two, right? So you have the access to ISQL Junior, and you have Notepad++ or something similar to that. Any text editor will work. So if you are using the Apple computer, maybe you can go to Google and say the text editors compatible with Apple operating systems. So you'll get a good text editor. There are plenty of text editors there. Okay. Right. So when you actually create this is actually a good thing to understand. Before we create the tables, we usually run some bunch of drop table commands, right? Because sometimes we may have the similar table in our database. So it's actually good practice first to drop that table and then recreate the table, right? So I run a drop table. In this example, I'm creating a movie table. So before creating the movie table, I run a drop table movie. So I'm deleting existing one and then creating the new one. Okay. So you will get this error message when you run the first time, because if you don't have a table called movie, if you get this error message, just ignore it, because it means that you don't have any table called movie in your database. But this is a good programming practice as well. First dropping everything and recreating the table, right? Right, so we have this in next week as well. Right, so this is how you execute. So just copy paste your commands or SQL statement and then press execute button. Right, so these are the advantages of Notepad++ because keywords will highlighted in blue color. Comments, now you can write the comments as well in Notepad or even in SQL. So there's usually comments we write in a two dash lines. Okay, so I will show you how to do the comments, and the numbers will be highlighted in red and the strings in this gray color. Okay, etc., etc. So don't worry about the functions because we are not using the functions in this semester. Right, so this is an example of Notepad++ codes. You can see the keywords highlighted in blue color, numerics in orange color, and then the varchar characters highlighted in the gray color. So this is the one advantage, as I mentioned before. Right, so this is another example how you use the user table commands. So I can access the data dictionary and see what kind of tables I have, and then I can see what kind of data types I have in each table by using this write command. So we'll practice this in next week, so you don't need to worry too much. So in this semester, we are not using any graphical user interface to drag and drop commands. Sorry, unfortunately, you need to write the commands by scratch. You are writing the codes, okay? So we are writing the codes because we are learning how to write the codes, okay? So when it goes to a more advanced database sort of subjects, probably you will use the graphical user interfaces. Okay. Yeah, so this is how the select statement works, because when you run the select statements, it will access the database management system will, send the command to the database, and then it will pick whatever which matches with the select statement and then send it back, the result set back to your screen, right? So it kind of has to go through, because actually it goes through your first it goes through your web interface, ISQL Junior, and then it goes to the RDBMS, and then it goes to a database, and then it comes back. Okay. So yes, so we use this ISQL Junior in this case this semester. But we are not going to actually produce more professional reports in this semester. We just populate the result set in our screen. Okay, but there are some other results generators or report generators available as a kind of add-ons that we can run this and produce some nice reports, but we are not going to use that in this semester. Okay. Right, so So actually, when you write the insert statement, the column names are optional. You don't need to specify column names. You can straight away write something like this: insert into the lecturer values, blah 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 blah. But don't use this. This is not a very good practice, I would say, because ignoring part of your insert statement is, but it's a shortcut. Sometimes programmers use this, but I personally don't like it, right? Because we don't know which columns these three values are representing. Because when you communicate your codes to your fellow colleagues in your team, development team, they might confuse. So it's good practice to write the column names. Okay, so that's not recommended.